So I'm going to talk about something that is hopefully near and dear to your hearts, which is time series visualization. Fancy word for metrics visualization. And more specifically, I'm going to be talking about Cubism.js, which is a JavaScript library that we just open sourced at Square last week, since I wrote the abstract for this. So I thought before I get into the details of how Cubism.js works and sort of looking at some examples of visualization, I thought it would be helpful to sort of step back and sort of consider, what is the value that visualization provides, and specifically within the context of monitoring production systems, because it's a hard enough question to answer that in general. So I thought it would be helpful to look specifically at sort of how we use visualization and what value it provides for production systems or monitoring of production systems. And I thought one way we could try to answer that question would be to look at sort of different use cases, like the ways that we actually use visualization in practice, and not just sort of theoretical, like charts are pretty and useful, but looking at specific concrete things that we do with them. So the first thing that came to mind, of course, was doing crisis diagnosis, right? So when you get paged in the middle of the night and something is wrong with your site, you want to figure out what's wrong with your site as quickly as possible. And very often, whatever alert generated that page is not sufficient information for you to solve the problem. If it was sufficient, then likely you would have just solved it automatically and it would recover, right? Like usually when you get woken up, when you have a crisis, it's something that you haven't seen before. And so it's the flexibility, the ability to see all of these different services interacting. That's the value that visualization provides in that context. It tends to be a lot faster than grepping through logs or trying to look sort of service by service to figure out what's going on. If you can see these things at a glance, then you can solve the crisis more quickly. Another situation where visualization helps is when you see something that you've never seen before, right? So some sort of abnormal activity, something that's unexpected. Obviously, if you expect certain things, then you can just set up automatic monitoring for them, or you can change your system design to avoid them entirely. So visualization is really there to detect things that you haven't seen before or that you don't fully understand. Another application for visualization is looking at capacity planning. So if you have simple things, then you can just do linear regressions and project that into the future. But very often, our systems do not have that simple behavior, right? They have some sort of spiky patterns. They're representative of human behavior, so they have like daily cycles or weekly cycles. And those things become much harder to model, particularly when you have things like weather and holidays and all these other things that are outside of your control, or like press announcements is another great one, right? Like you get featured on Hacker News. Are you going to be able to handle that sort of load spike? So visualization can help with that as well, in the sense that it's a bit more resilient. You can sort of eyeball these things, and maybe it can help guide you in the construction of a better model. And then lastly, sort of more generally, just by having an increased understanding of how these systems work, you can use that as empirical information and sort of improve the system design, rather than just sort of guessing or going with a hunch. So if those are the use cases, then that sort of corresponds to some of the benefits that I've already talked about. Right? If you have the ability to diagnose these crises faster, then you're reducing the impact of some sort of problem. If you discover some unexpected or anomalous behavior before it causes problems, then you're doing a great job as well. You're preventing downtime from ever occurring. And of course, if you have this increased situational awareness, like you're aware of how your system performs under load and up to real time, then you can make better decisions about sort of, let's say, when you perform maintenance or how you change the design of your system to make it more robust. Now, if those are the values, or that's the value that visualization can provide, the flip side is that it's not sort of this magic cure or this panacea. There's a lot of thinking that has to go into using visualization effectively. It's a tool. Like any other tool, you have to know its limitations and how to use it appropriately. And a lot of this actually comes from sort of the strengths and weaknesses of human perception, which isn't sort of, well, we understand a lot of things about human perception, but there aren't always these concrete rules that you can apply very simply to improve your design. So you have to think hard about how to build these visualizations to make them effective. So some of the things that can make visualization difficult, for example, you have to recognize that data is not information. So it's tempting to just sort of report a metric and be like, okay, once it's in graphite, like my job is done. But very often that's far from true. For one thing, like other people may be consuming that information who don't have the same context, right? So the discoverability of metrics can be important as well. And also you very often have to do transformations or even just simple transformations of that data for it to be meaningful. So like for example, if you're using collect-D to monitor CPU utilization, that's one of these monotonically increasing counters, and you need to compute the derivative of that in order for it to be a useful value. But also like you've got 8 cores or 16 cores or however many number of cores on your machine, and you have to make a decision, do I want to sort of aggregate all of those cores together, or do I need to be able to monitor each of those cores individually? Because with certain applications, that might be appropriate or not appropriate to do that. And then in terms of human perception, there are all these other considerations as well. Excuse me, just swallowed some air. So there are different visual channels that you can use in visualization, and some of them are more effective than others. And there's also a limitation to the number of channels that you can use at the same time. If you're interested in this thing, there's a whole bunch of stuff to read. Like Jacques Bertin is this French founding father of visualization, and he has this thing called the matrix theory of graphics. And he basically establishes that there are really sort of 3 dimensions that you can use at most before you suffer from integrality, which is where these different visual channels sort of start interfering with each other and making it harder to perceive the data. And so those 3 dimensions are x and y, which are just the 2 dimensions of the plane. So like if you have a scatter plot, for example, that's x and y. Those are 2 dimensions. And then the 3rd dimension, which is z, which I forget what he called it exactly, but like some sort of light energy or intensity or something. And that's basically like color or shape or texture or all these other things that you can do to a particular glyph that's already positioned on the plane. So a lot of the effective visualizations, right, you're using an area chart or using a line chart or a scatter plot. These are all primarily position encodings, which are good. Once you start to try to combine a lot of things together, right, like using multiple color channels is a good example of something not to do, it becomes harder to perceive those individually. So don't try to do too much with a single visualization. Another issue is that you can't sort of perceive all colors equally. I'm going to show you a couple examples. It will be especially bad on this projector screen, especially with the sun shining on it. And then lastly, like doing it right takes time, right? There are all of these design decisions that go into coming up with a good visualization. So don't set your expectations too high. Like there's no free lunch. All right, so some examples of things not to do. So this is a stacked area chart. And one example, one bad thing about this, there are many things that are actually bad about this. But one is that it's just so noisy. The aspect ratio is way too tall for this chart. Typically, you want to design a chart so that well, it's more complicated than that, but the average slope of the line should be 45 degrees. And you can see with this chart, they're all about 90 degrees. They're just going up and down constantly. So it's very difficult to perceive sort of the overall shape of this area chart. It's even harder to perceive sort of the individual layers. And that's because when you have this stacked area chart here, you can sort of see this bottom blue layer fairly easily. But the layer above is now offset by the layers below. So if there's a bump in the layers below, then it's really hard to tell what's going on with the layers above. So these sort of charts are effective for looking at sort of one layer at the bottom and for the overall envelope, but they really aren't that good at showing you all of the series. So you're paying sort of a high cost by trying to combine these things together into a single chart. Likewise, if you try to use a line chart here, again, aspect ratio is horrible, but all of these things are sort of crossing over each other, so it's really difficult to sort of perceive, to pull an individual series out of this chart. And also, like, these are the default colors used by graphite, and they're horrible colors. They're basically fully saturated, and we don't, like I was saying earlier, we don't perceive all hues equally. So like this yellow color, it's actually darker on this projector, which is interesting, but this yellow color is normally impossible to see against a white background because yellow is a very bright color, whereas a color like blue or purple or dark red is going to stand out. It's much stronger against a white background. So it's helpful to pick colors that sort of have more uniform distribution and have been thought or been sort of more thoroughly planned out by other people that have sort of a lot of expertise in this area. So lastly then, if we think about sort of other places where we can improve visualization, most of the systems that I've seen tend to just produce a static image, right? They have all of the data living on the server, you make some request, and it's just returning you a PNG or a JPEG or whatever. And that's really not taking advantage of all of the features that we have in modern browsers, and those features being able to make visualization more effective. So one thing, for example, if we're looking at real-time data, we don't need to re-render the entire thing every 10 seconds that go by. And that can greatly improve the performance or reduce the load on the server. But also in terms of interaction, we can make these things much richer. Right? You can have a nice overview, but then you can have the ability to pan and zoom to look at sort of one specific series in detail, to read exact values, to do sort of all these different types of analysis on top of these charts. And simply by choosing an architecture that can only serve static images, you basically make that impossible. So it's important that we move forward and we take advantage of all of the features that modern browsers have. So an example of that, sort of a good technique that you can use, that does a better job of visualizing time series data as horizon charts. And they require a little bit of explanation, but they're actually not that complicated once you've used them for a while. So this here is just a simple area chart. It's actually some employment data, but what I've done is I've taken the negative values here, which are blue, and I've inverted them. So normally this would go sort of below the axis and then back up. And all I've done is take those negative values and invert them. And the other thing that I could do instead would be to take these negative values and sort of shift them up from the axis. Right? So these are the negative values and these are the positive values, and sort of time along the x-axis here. Does that make sense to everyone? OK. So all we're doing with a horizon chart is taking this same representation and we're going to compress it vertically. And the important thing is that as we compress it vertically, we're not actually losing any resolution. So I just cut the amount of vertical space in half by folding it and then using a darker color to distinguish these two different bands. Now, I imagine it's kind of hard to see on this projector, but like this is a lighter color blue, this is a lighter color green, and this is a darker color green. Can people see that? So notice as I sort of move back and forth here between one band and two band, this shape doesn't change, right? The sort of size of these peaks and valleys has stayed the same, even though I've cut the total chart size in half. And what that means is that the resolution in terms of position in this chart is exactly the same as it was when it was twice as tall. And the reason that I'm able to do this like miraculous thing where I haven't lost any information, but I'm now taking up half the space, is that I'm combining position and color. Right? If you take an area chart that is normally 100 pixels tall, and you compress it down to 50 pixels, normally you would lose half the resolution. But what horizon charts do is by combining color with position, they let you reduce the amount of space while keeping that same resolution. So in fact, you can sort of keep adding as many layers as you want, and it keeps getting smaller and smaller. And you can go all the way down to 100 bands if you want. But then the problem is you no longer can distinguish these colors as effectively. Right? It's much easier to distinguish a few different bands of color than it is to distinguish hundreds of colors across the entire spectrum. And that's because color is really good at encoding ordinal information, which is sort of these discrete categories, versus position, which is really good for these quantitative values. So basically, you can choose sort of any point along the continuum here in terms of how many bands you want to use, how many colors, and how much vertical space that you have. In practice, I wouldn't recommend using more than 4 bands, which is the default that Cubism uses. If you were using a projector, then I would only use 2 bands. So the advantage of doing this is that now, where before you would require hundreds of monitors in order to see all of this information, you can now fit it in a single screen. And I can make this sort of interactive example here, and then scroll up and down. So these are all random data. I have a couple more interesting examples, but these are the interactive ones. So in this case, these are just a random walk combined with some sinusoidal function. And so you can see up here, like these are the lower frequency values versus down here, these are higher frequency. And then it's a bit hard to see on this projector, but there's sort of this vertical band here that lets you compare values at any point in time. So again, all of these charts share the same x-axis. Each of these are individual spaces that you've allocated for each of your metrics. The idea is that it's very easy to now compare each metric on its own, or look at each metric individually, because it doesn't share the same space, right? You've avoided that integrality or interference problem that you have with like stacked area charts or with line charts. But because they all have the same x-axis, it's very easy to look at things that occur at the same time across metrics. So I'll give you a better example of that. This is real data. Unfortunately, like the projector or whatever is cut off, it doesn't really matter. This is some stocks that I pulled from Yahoo Finance. These are all like daily values, going back to like sometime in 2009. So right, you can see like there are certain patterns that go across multiple stocks, right? Like there was some volatility and a big sort of decrease on this date. It affected some of these stocks more than others. Or like just sort of nice general increases, like should have invested in Baidu. So that's the basic idea, right? You've got these horizon charts, and now you have the ability to compare hundreds of metrics at the same time. And you don't suffer from these like integrality problems. All right, so these examples were built with Cubism.js, which is open source. It's Apache licensed, so it's pretty much free for you to use however you like. You can do it right now. You can stop listening to me. But I'm going to walk you through a little bit sort of how it works behind the scenes so that you sort of have a head start. One of the key ideas is that there's a context which is coordinating all of the updates for these charts. And the idea is like you want to specify the resolution of data that you want to display and also the size of the display. So normally with these things you might say like I want to display 4 hours of data and I want my chart to be 800 pixels wide or something like that. Cubism is a little different. You still say that your chart is, in this case, 1440 pixels wide, but you actually specify what you want the resolution of each pixel to be. So in this case, I've said 10,000, which is 10 seconds in milliseconds. And the reason for that is that that sort of sets the optimal resolution for how you're going to display it. So you don't have to worry about accidentally loading too much data or too little data. It's very easy, for example, in Graphite to say, you know, I want to look at the last 7 days worth of data, and I want an 800 pixel wide chart, and you forget to say, like, summarize 5 minutes or something like that, and all of a sudden you've loaded 60-something times too many data per pixel that you're going to display, right? And that's going to make your Graphite server sad, and that's going to make things fall over when you're trying to, like, diagnose these crises or whatever. So I've already explained these things. Oh, and another aspect is that you've got now a central sort of component which is coordinating all of these updates. Right? So all of the data is coming from some other server. That could be Graphite, it could be Cube, it could be Splunk, it could be whatever else you use to store your data. It's extensible. But those data fetches are all asynchronous. They're going to come back at different times, particularly if you have hundreds of things that you're looking at and are all updating in real time. But you want to make sure that whenever you update the display, it all sort of clicks with sort of Swiss precision. Because if everything is updating independently, that becomes much harder for you to look at it because you're always being distracted by this little bit of motion that's happening in the corner of your eye. If you've ever tried to read an article where there's a blinking ad on the side of the page, you know exactly what I'm talking about, right? So the idea here is to coordinate the updates, and that also makes it much more efficient. Now, I mentioned like these data sources. Graphite is just one of the data sources that you can use with Cubism. It's also extensible if you want to write your own data source. If you've rolled your own internally, you can do that as well. And then given a data source, you can create all of these metrics from it. So this is just a Graphite expression. And now I've got a metric that I can use to visualize. And I can take that metric and give it to a horizon chart. And then that horizon chart is how I'm going to display it. But of course, the horizon chart is only one of the types of charts that you can use. There's another chart which is called a comparison chart, which is really useful for doing comparisons between a primary metric and a secondary metric. So for example, if you have a canary host and you want to compare something experimental you're doing on that canary to a normal server or to the average behavior of servers, you can do that. Or if you want to compare one metric to, say, that same metric time shifted to be a week ago, you can use a comparison chart for that. These are a couple examples of data that, or how we're using it internally at Square. So this is a CPU chart where we're looking at CPU utilization at 10-second intervals. And there's some interesting patterns here, like see these sort of staggered, sort of time-shifted patterns. That is us doing like a rolling restart, like we're doing some job on those machines, but we're doing it on one machine sort of after taking it out of the load balancer, waiting for it to finish, and then once it's done, we're switching off to these other machines. And if you were doing a stacked area chart, you would never see these sort of things because it's having each metric have its own space that gives you that sort of precision. Another example, like this is looking at network utilization at the same resolution. But now I've got pairs of metrics. So the green is incoming network traffic to a particular host, and the blue is outgoing network traffic. And all I did is invert the blue so that they're sort of paired together. And you can see these cases like streaks that occur across hosts. Like we run rescue on these hosts. So if you start up a whole bunch of tasks, then you can see sort of spikes of activity that sort of span across your hosts. Or if you were to like get a DOS attack or something like that, and then you would see a lot of activity across hosts. Likewise, you can change the time scale here and start to see sort of more daily or weekly patterns, or like spikes of activity. And this is the one that's sort of really helpful for doing that capacity planning, like knowing how close you are to the limits or whether like certain design changes or code changes that you've made have improved performance or improved the robustness of your design. Sort of you want to take a little bit of that longer time frame. Now, the metrics are also composable in the client, which is nice to have that like extra layer of flexibility. Like you can do some composition with graphite, for example, like some series, and like our graphite install humorously has divide series, but it doesn't have multiply series because I guess those were added in different releases. But not to worry, like you can do it yourself in the client. You can also do sorts of crazy things like weighted averages. So you take a whole bunch of hosts, multiply those together in series, and then combine them down to a single result. Cubism also has time shifting built in. So if you're using a backend that has time shifting built in already, like Graphite, that's great. But Cubism can do that for you as well transparently. So like this is an example where we're taking some metric foo and we're computing the percent change over the last week just by taking two of those metrics that are time shifted. And I haven't talked at all about D3, but that's sort of, well, I spend a lot of time working on D3. It's kind of my baby. And Cubism is a D3 plugin. So what that means is it's not, you use D3 in conjunction with Cubism. So to create these metrics, you're not sort of instantiating all of these individual charts. It's more of a data-driven approach where I have, like in this case, an array of metrics, and then I'm sort of declaratively specifying all of the charts that I want to create for those metrics. And that adds sort of another layer of flexibility in composing your dashboards. And so lastly, like if you've seen Cube, for example, which is a project that I did earlier, and I'm still working on actually, Cubism is the sort of offshoot of Cube, trying to take a different approach to how visualization is done. The reason that we built Cubism rather than Cube, which had a graphical front end, is there's just so much more that you can do with a simple JavaScript library than I can do by building a comprehensive UI front end. And the other thing that we've discovered is nearly everybody is comfortable with doing some limited sort of JavaScript programming to compile or to assemble these dashboards. Like it doesn't have to be rocket science. They can be relatively simple. But just by having these sort of small orthogonal components, you now have a lot more flexibility in assembling these dashboards. So it's a joy for me to work on because it's much easier for me to add sort of new features to it, and also to see like how people can use it in different ways. Like we've already been working with some guy from Splunk to sort of integrate Cubism, talking to Splunk services. But there's just like a lot of possibility as well in terms of how people use Cubism. So I hope you guys will all check it out and let me know how it works for you. Thanks.